All right, let's get into it. Today, we're going to pull back the curtain on something that's kind of like the invisible architecture behind, well, everything. We're talking about the science of construction planning. It's the reason these massive projects don't just happen, they happen right. I mean, have you ever really stopped to think about it? You see a new skyscraper, a massive bridge, or a stadium going up. We're talking thousands of people, mountains of materials, millions of dollars. So many moving parts. How on earth does a giant building just appear from a hole in the ground in a few years without turning into total chaos? Yeah, it's definitely not magic, and it's not just good luck either. It's a science, a really disciplined, systematic science that's all about taming pure, raw complexity. So how does it all work? Okay, let's break it down right from the very beginning. So what we're really digging into here is the art and science of project management. You can think of it like a giant, crazy three-dimensional puzzle. And the pieces? They're time, money, and resources. And that final picture? It has to be absolutely perfect. Okay, so this is really the core of it all. It boils down to one simple, powerful word: control. Project management is all about having the right tools to control the schedule, control the cost, and control the quality. Get those three pillars right, and you've got a successful project. Get them wrong, and, well, you've got chaos. So the big question is, how do you even begin to control something that complicated? Well, you start by seeing it. You have to visualize it. And for more than 100 years, the very first step has always been this one simple, really elegant chart. And here it is, the bar chart, or as it's probably better known, the Gantt chart. I mean, it is just brilliant in how simple it is. You've got your list of tasks, right? And then you've got time running across the bottom. Each bar shows you exactly when a task starts and when it ends. It's an amazing way to see the what and the when all in one quick glance. But, and this is a big but, for all its simplicity, the Gantt chart has this huge blind spot. There's this supercritical piece of the puzzle that it just can't show you. Any guesses what that might be? Dependencies! That's the one. It's that whole chain of events, You can't paint the walls until the drywall is up, and you can't put up the drywall before the wiring and the pipes are in. A simple bar chart just doesn't show you how all those pieces are connected. It doesn't show the domino effect. So, to fix this huge problem, project managers needed something totally new, a real breakthrough. They needed a tool that could map out not just the tasks, but that whole complicated web that connects them all. They really needed to, connect the dots. And that's where the network diagram comes in. Now, this is a whole different ballgame. It's not just a list anymore, it's a map. Every task is a destination, and the lines between them, that's the road you have to take. The exact sequence of work, this is the tool that finally lets you see that hidden web. Now, inside this world of network diagrams, two main approaches really took over: PERT and CPM. They might look kind of similar on the surface, but they were actually built to handle two very, very different kinds of projects. So here's the main difference. It all comes down to how much you know. PERT is what you'd use for something super unpredictable, like a research and development project. You don't know how long it'll take, so you make 3 guesses: an optimistic one, a pessimistic one, and your best guess. But construction, that's way more predictable. We pretty much know how long it takes to pour a foundation. That's why construction loves CPM, the critical path method. It's deterministic. You use one solid time estimate because you're confident you know what you're doing. And this is what brings us to the absolute heart of the critical path method. Once you've laid out your whole project map, all the tasks, all the connections, you have this aha moment. You realize that not all tasks are created equal. Some are way, way more important to your deadline than others. And that right there is the critical path. Imagine tracing every possible route through your project map from start to finish. The one that takes the longest amount of time? That's it. That's your critical path. It's basically the time-based backbone of your entire project. And you have to get this. There is zero, and I mean zero, wiggle room on the critical path. If any single task on that path gets delayed by just one day, the entire project's finish date gets pushed back by one day. It's a direct one-to-one delay. This is why project managers are absolutely obsessed with the critical path. Okay, so what about all the other tasks, the ones that aren't on the critical path? Well, those lucky tasks have something called float or slack. And that's exactly what it sounds like. It's the wiggle room. It's the luxury of being able to delay a task for a bit without tanking the whole project's deadline. And this wiggle room, this float, actually comes in a few different flavors. The big one is total float. That's the maximum amount of time a task can be delayed before it messes with the project's final end date. But then there's also free float, which is super useful. It tells you how long you can delay a task before it affects the very next activity. Knowing the difference between these gives managers this incredible flexibility to move people and equipment around to solve problems, all without starting a catastrophic domino effect. All right, so we've got a handle on the timeline, right? We've got our critical path, we know our float, but there's this whole other side to the coin, and it's just as important: money, the budget. And believe me, this is where the really tough decisions get made. First things first, we need to get a handle on the two types of costs. You've got your direct costs. That's the money for the actual work, right? Paying the crew, buying the materials, renting the cranes. Then you've got indirect costs. Think of this as the project's overhead. The site office, the insurance, the security guards. This is the stuff that costs you money every single day the project is running, whether anyone is working or not. It's like a meter that's always running. And that brings us to this really cool concept called crashing. So imagine you're falling behind schedule. Crashing is when you strategically decide to spend more money to speed things up. Maybe you pay for overtime, or bring in a second crew, or rent a bigger machine. Sure, your direct costs for that task go up, but here's the kicker. If you can shorten the whole project, you could save a ton of money on those daily indirect costs. But of course, you can't just start throwing money at the problem. You gotta be smart about it. You need a way to figure out where your cash is going to make the biggest difference. And that's where this metric comes in, called the cost slope. Okay, I know, the formula might look a bit scary, but trust me, the idea is super simple. All the cost slope tells you is this: for any given task, how much money does it cost to save 1 day of time? That's it. It's basically the bang for your buck calculation for buying time. And this is the golden rule of crashing. You only crash activities that are on the critical path. Why? Because speeding up anything else is a waste of money. It won't make your project finish any sooner. And you always start with the critical path activity that has the lowest cost slope, the cheapest one to speed up. That is how you strategically, efficiently buy back time and potentially save a fortune on those overhead costs. Which all brings us back to the ultimate question, the one every single project manager has to answer. You know how to finish faster, you know exactly what it's going to cost. The real question is it worth it? And that constant, high-stakes balancing act between time and money, that's really what building our world is all about.